Hello everyone, in this video I'm going to be finding for the radius and interval of convergence for this series that I have written here. So we're going to be using the root test, and when we use the root test we have to take the limit as n approaches infinity of the absolute value of a sub n to the power of 1 divided by n. Here, a sub n is just this, our series. So if we just substitute that n, then we'll have the limit as n approaches infinite of the absolute value of 2 to the power of n times 4 times x minus 8 to the power of n divided by n. All of this to the power of 1 divided by n. Okay, now we can, let's take, 2 to the power of n, and if we also include this, then we'll have 2 to the power of n divided by n times, we'll have 4 times x minus 8 to the power of n divided by 8, n divided by n divided by n to the power 1 divided by n. This is just equal to 2. So as the limit as n approaches infinite of absolute value of 2 times, this is equal to 4 times x minus 8 divided by, my brother made a video on this, on the limit as n approaches infinity of n to the power 1 divided by n, which is what we have here. And he proved that this is equal to 1. So we'll just write 1 here. And since we don't have any more n values here, we can just conclude that this limit equals to 2 times this, but we can factor this, right? 4 times x minus 2. And this is equal to 8. We need the absolute value since we can't just get rid of the absolute values on our own. And since we're trying to find for the interval of convergence and the radius of convergence, we have to set this smaller than 1, since when we use a root test, it converges when our limit is smaller than 1. So here we're going to divide 8 on both sides, and we'll get absolute value of x minus 2 is smaller than 1 divided by 8. We're going to use this type of form, x minus c. Absolute value of x minus c is smaller than r. The c will be the center, and the r is the radius. Here, the c is equal to 2 and r is equal to 1 over 8. So we already found the radius of convergence, which is equal to 1 over 8. And now we're going to try to find for the interval of convergence. To find for the interval of convergence, we're going to also add negative 1 over 8 here. So negative 1 over 8 is smaller than absolute value of x minus 2. And this is smaller than 1 over 8. Add 2 on both sides, and you have 2 minus 1 over 8 is smaller than x, which is smaller than 1 over 8 plus 2. If we calculate this, then we'll get 15 divided by 8, which is smaller than absolute value of x, and that is smaller than, if we calculate this, then we'll get 17 divided by 8. So this will be our interval of convergence, but the thing is, we don't know if it converges or diverges at x is equal to 15 divided by 8 and 17 divided by 8. So we're going to have to put in x is equal to these two numbers into our original series and see if it converges or diverges. Okay, let's put in x is equal to 15 divided by 8. If we do that, if we put in x is equal to 15 for this series, then we'll get the series n to the 2 to the power of n times 4 times 15 divided by 8 is equal to 15 divided by 2 minus 8 to the power of n. Divide this by n. So this will be our new series. Let's calculate this. 15 divided by 2 minus 8, which is, 8 is 16 divided by 2. So our new series will be 2 to the power of n times negative 1 over 2 to the power of n, and divide it by, I'll actually just keep two of these separately. And that is equal to 2 to the power of n divided by n times, let's put the negative on the top next to, in front of the 1, and we'll have negative 1 to the power of n divided by 2 to the power of n. We can cancel out the 2 to the power of n's, and what we'll get is an alternating series. To find out whether this series converges or diverges, we can use the alternating series test. The limit as n approaches infinity of absolute value of a sub n, which is 1 divided by n, this approaches 0. So it passes the first test of the alternating series test. Then 1 divided by n plus 1 is smaller than 1 divided by n. This is true, so it passes the second test. So now we can conclude that this series converges. Now that we know that the series converges at x is equal to 15 divided by 8, we can add this line. And now let's find out if the series converges or diverges at x is equal to 17 over 8. So at x is equal to 17 over 8, we'll have the series 2 to the power of n divided by n times 17 over 8 times 4 is 17 divided by 2 minus 16 over 2. 8 is 60 over 2 and it's the power of n. Calculate this and we just have 1 over 2. 1 to the power of anything is just 1, so we can just move the n to here. Well, yeah. And these two cancel out, and we'll just be left with the harmonic series 1 divided by n. We all know that this series diverges, since this is a p series and p is equal to 1. So this series diverges, which means that here they don't get a line under here since it diverges. So this will be our interval of convergence. So our interval will be 15 divided by 8 is smaller or equal to absolute value of x, which is smaller than 17 divided by 8. Thank you for watching, everyone. In this video, I cleared up finding for the radius and interval of convergence for this series. And I hope you understood my explanation. So have a great day.